Welcome to day 13 of the KobeCloud 100 Days of DevOps Challenge. In today's video, we're going to learn how to secure Linux servers using IPTables. You'll see how to install and configure IPTables, restrict Apache access to trusted hosts, and protect application ports in a real production-like environment. This is a hands-on DevOps lab where we apply Linux firewall rules step by step, exactly the way it's done in real data centers. If you're learning DevOps or Linux system administration, this session will help you understand how network security is actually implemented on servers. Let's get started. First, I log into the application server using the Tony user account. I connect to the server securely over SSH from the jump host using Tony's credentials. Once the login is successful, I'm inside the app server where Apache is running, and this is the server we're going to secure using IPTables. Once I'm logged in as Tony, the first step is to install IPTables and its services on the server. I use the yum package manager to install both IPTables and IPTables services. This installs the firewall software along with the service scripts we need to manage rules and make them persistent. After installation, the server is ready for configuring firewall rules to secure our Apache service. No. After installing IPTables, the next step is to enable and start the service so it runs immediately and on every reboot. The first command ensures that IPTables will automatically start whenever the server reboots, and the second command starts the firewall service immediately. Now the server is ready to have rules applied to secure the Apache port. Once IPTables is running, the next step is to identify the load balancer IP, so we know which host should be allowed to access Apache. I do this by viewing the /etc/hosts file using. This shows all the server host names and their corresponding IP addresses. From the output, I can see the load balancer host STLB01 has the IP 172.16.238.14, which is the only host we will allow to access Apache on port 6200. This ensures we secure the server while still allowing traffic from the load balancer, SUMS. Before adding new firewall rules, I first flush any existing IPTables rules to start with a clean slate. This clears all current rules from the input, output, and forward chains, ensuring there are no conflicts with the new rules we are going to apply. Flushing the rules is a safe step when configuring IPTables from scratch in a lab or production environment. Now that the existing rules are cleared, I add a rule to allow the load balancer to access Apache on the required port. Here, 172.16.238.14 is the LBR IP, and 6200 is the Apache port we want to secure. This rule ensures that only the load balancer can connect to the Apache service, while all other hosts are blocked later. This is an essential step in securing application traffic in a production-like environment. After allowing the load balancer, the next step is to block all other incoming traffic to the Apache port. This rule drops all TCP connections to port 6200 from any IP that is not explicitly allowed. By combining this with the previous rule for the load balancer, we ensure that Apache is only accessible from trusted sources. This is a key security measure to protect our servers from unauthorized access. Next, I add a rule to allow established and related connections. This ensures that ongoing sessions, like SSH connections or responses from clients, are not interrupted by the new firewall rules. This is an important step in any firewall configuration to maintain stable network communication while enforcing security rules. It allows the server to respond to legitimate traffic without opening unnecessary ports. To make sure we don't lock ourselves out of the server, I add a rule to allow SSH connections on port 22. This ensures that remote administrators can still connect to the server via SSH, while all other unnecessary traffic is controlled by our firewall rules. It's always important to allow SSH before applying restrictive rules to avoid being cut off from the server. Next, I make sure that the server can communicate with itself by allowing all traffic on the loopback interface. This is important because many system processes rely on the loopback interface, LO, to communicate internally. Blocking this could cause unexpected errors, so we always allow it when configuring firewall rules. After adding all the necessary firewall rules, the next step is to save them so that they persist even after the server reboots. This writes the current rules to the system configuration file, ensuring that the firewall settings are retained across reboots. Now, our server is secured and the rules we configured will remain active automatically. Once the rules are saved, I verify them to make sure everything is applied correctly. I use the following command to list all IPTables rules along with their line numbers. This displays a clear, numbered list of all rules in each chain, showing which ports are allowed, which are dropped, and which IPs have access. It helps confirm that the load balancer is allowed on port 6200, SSH is open on port 22, and all other traffic is blocked as intended. After verifying the rules on STAP01, I exit back to the jump host. From the jump host, I repeat the same IPTables installation and configuration process on the other two application servers, STAP02 and STAP03. This ensures that all our application servers have consistent firewall rules, allowing only the load balancer to access Apache on port 6200, while all other traffic is blocked. By applying the rules uniformly across all servers, we maintain a secure and predictable network environment in our data center. After configuring IP tables on all three application servers, I returned to the jump host to test connectivity. I ran curl HITTP yush stap 01:6200. However, there was no response because our firewall rules block all traffic to port 6200 except from the load balancer. To confirm that the load balancer can still access the service, I logged into the LBR host and ran the same curl command. Curl HTTP duar saw stap 01:6200. This time, the request was successful, showing that the firewall rules are working as intended. Only the load balancer can reach Apache, while the jump host and other sources are blocked, completing the secure configuration. And that wraps up Day 13 of the KobeCloud 100 Days of DevOps Challenge. Today, we learned how to install and configure IP tables, secure Apache access, allow only the load balancer to connect, and make our firewall rules persistent across reboots. These steps are essential for securing Linux servers in real-world DevOps environments and help you understand how network security is implemented in production. If you found this tutorial helpful, don't forget to like, subscribe, and hit the notification bell so you won't miss the next day of our 100 Days of DevOps Challenge. Stay tuned, and I'll see you in Day 14.